Okay guys, today we're going to do chapter 2.2, Limits Analytically. Analytically, first off, that word right there, analytically, means algebraically. So we're dealing with limits on functions. Okay, let's start this up. Okay, first thing, find the limit as x approaches -1 with the function negative x squared plus 5x minus 2. Okay, first thing to start you guys off is I'm going to show you a graph and a table because you guys should know how to do limits with these two things. If you do the limit as x approaches -1 with this table, you will see from the left you are approaching a y value of -8, and from the right you are approaching a y value of -8. Therefore, we know the limit as x approaches -1 is -8. You can see the same thing over here on this graph. Let me grab a pen here. Okay, you can see the same thing over here on this graph. Just copy down all the way until you hit the graph. Looks like it hits around here. So -1, 2, 3, 4, 5, 6, 7, 8 is about where that -1 value would hit. And from the left, it is approaching -8, and from the right, it's approaching -8. Okay, so how you would do this on just a regular function. First, you would just plug it in and see if it gives you a value on the function. And if it does, that's going to be your answer. So let's just see how it works on this one. So -1 squared plus 5 times -1 minus 2. Okay, that comes out to -1 squared is 1. Then you have the negative sign out there, so it's going to be -1. And then 5 times -1 is -5 minus 2. And that comes out to -8. And there you go. That is the limit as x approaches -1 on the graph, on the table, and analytically. Okay, so let's go over to our next PowerPoint slide. These are going to be the steps in order to solve any limit analytically for now, okay? So first thing you're going to do is you're going to substitute the value in, just like we did, okay? If it gives you a number, that's your answer. Like right now when we did the other one, the answer was -8. If it gives you any number divided by 0, then you need to go to the next step. Because remember, any number divided by 0, like let's say you get 5 divided by 0, that's not possible. That is undefined. And when you get something undefined, that means you ran into a discontinuity. Okay? So what we're going to do is we're going to go on over to the next step, and we're going to factor and cancel. And remember, by factoring and canceling, you get rid of the removable discontinuity, which is you remove the holes. Remember, this step removes the holes, and then you can now use this new equation you have to plug in the answer that you have. If it also gives you something divided by 0, so let's say now you plug it in after you remove the hole and you get 4 divided by 0, which is undefined. Okay, now that means we're going to come over here, and that means the answer is going to have a vertical asymptote. That means our function has a vertical asymptote. That's a discontinuity as well, right? That means our answer is either going to be something like this, okay, where let's say this is our x value 2. Okay, so let's do all of these at 2. The limit as x approaches 2 of our function. On this one, the limit as x approaches 2 would be infinity. Okay, let's look at the next one. Let's come up with another one. Okay, on 2. Let's say it approaches positive infinity on one side. On the other side, it approaches negative infinity. Okay, well that would be D and E. It doesn't have a limit at 2 at that point. These are both vertical asymptotes, right? Okay, and then the last option you might have is you might have a graph where it goes down on the left-hand side and it goes down on the right-hand side. And that would be a vertical asymptote. Your answer on this one would be negative infinity. Okay, that's why our only answers are positive infinity, negative infinity, or D and E, because there's only 3 options here. You either have the left-hand side going up and up, The left side going up and the right hand side going down, or both of them going down. And in order to do this, you go a little to the left and a little to the right. And I'll explain these as we do them. So let's just go through a few of them and get the answers for you. Okay, so first we're going to deal with it if it has no discontinuity. This would be a function without a discontinuity. It's a polynomial, and this would be a function that did not have a discontinuity. If it doesn't have any problems of dividing by 0, you should get the answer on step 1. So let's do one that looks like that. Okay, here we go. Now remember, we're going to do step 1, okay? Always start at step 1. Let's plug in our number into both the x values and see if it comes out to be an actual answer here. So -1 plus 3 over -1 minus 1, which is going to give us -1 plus 3 is 2, divided by -1 minus 1 is -2, and that would give us an answer of -1. Okay, so that's our answer right there. It gave us something that was not dividing by 0, so there's no discontinuity there, and that's our answer. So let's look at it on a graph and a table. Okay, here's a graph of it, and we are approaching -1, remember, so that is right here. Okay, that's this value right here. If you look at it from the left, it is approaching a y value of -1. From the right, it is approaching a y value of -1. So graphically, it is -1. Let's look at it tabularly. From the left, it's approaching -1. From the right, it's approaching -1. From the left, it's approaching -1. From the right, it's approaching -1. Yeah, left and right. Okay, so that's how you would do that problem if there was not a discontinuity at your x value that you're checking. Okay, let's go to the next one. Okay, now we're going to be dealing with a discontinuity if there's a hole. So here you can tell there's a hole because if you look at it here, there is two things that cancel out, right? The x plus a and the x plus a both cancel out. So I know there is a discontinuity at -a. I actually put it at +a here. That's a mistake. Okay, there's actually a discontinuity at -a on this, and we canceled it out, and our new function is x minus b. Okay, so let's do a problem with this. Okay, we got this problem. Remember, always start with step 1. I just suggest always doing that. So let's plug in first. So this is step 1. Okay, we plug in -2 squared minus 2 times -2 minus 8 all over -2 squared minus 4. Okay, so we got -2 squared is 4 plus 4 minus 8 all over. And if you look at this, this is all that really mattered here. This is 4 minus 4, which is 0. I don't even care what the top came out to be. I am dividing by 0. Step 1 did not work for us. Get rid of it. I got to go to step 2. Okay, so step 2 is I got to factor and cancel. Maybe there's a hole here. Okay, there might not be a hole. Maybe you can't factor and cancel. But in this case, I have a feeling it will. So let's put an equal sign here and see if we can factor anything out. Okay, the bottom is going to be x plus 2x minus 2. Okay, and the top, it looks like we got an x on both of these. Probably be 4 and 2. Let's put a 4 and a 2. And it looks like the middle is going to have to be -2, so I'm going to need this to be a negative and this to be a positive. Okay, so there is a hole on this one. Look at this. X plus 2 cancels out with x plus 2, and we're left with a new function. This is our new problem here. The limit as x approaches -2 of our new function x minus 4 over x minus 2. Okay, now we're going to plug it in and see if it gives us an answer. See here. So -2 minus 4 all over -2 minus 2, which comes out to -6 over -4, simplifies to 3 over 2. It gave us an answer. That's it. That's the answer, 3 over 2. There was a hole, we removed it, hence the term removable discontinuity. That's our new function. We can deal with this function as being the function that looks just like this one, just without the hole. Yeah? If you graphed this function right here, if you graphed this and graphed this next to each other, they would look the exact same, except this hole at -2 would be removed. That's the only thing that would be different about these two graphs. That's why I can act like this is my new function. I can plug in -2 and see where was it approaching from the left and the right. And let's look at a graph of that. Okay, from the left, okay, we were talking about at -2, right? That means right here about this value. Okay, from the left, we are approaching about 1.5, which is the same as 3/2. From the right, we're approaching the exact same thing, about 3.5. Look at it from the table. As you go from the left-hand side, it is approaching a hole that is 1.5. From the right-hand side is approaching a hole that is 1.5 as well. So our limit as x approaches -2 is 1.5. It's 3/2. Okay, let's go to the next one. Okay, now what we're going to be talking about on this one are vertical asymptotes. This is the last thing. Okay, we did step 1, step 2. This is step 3. Step 2 doesn't work. Okay, nothing cancels, so there is a vertical asymptote at -c. That's this vertical asymptote. It's at -c. Our answer is either going to be, this is the one that I was just talking about. Okay, so our answer is either going to be like this, where it does not exist. The limit as x approaches -2 on this one does not exist. Or it'll look something like this, where both sides are going up, and your answer would be infinity. Or it's going to do something where both sides are going down, and your answer would be -infinity. So the only answers you can get on this one are D and E, infinity, or -infinity. Okay, let's go to the problem and try it out. Okay, I got 2 problems to try out on this one. I'm just going to do this one over here, and then I will leave this for you all to do. I'll tell you what the answer is though, so you'll know if you did it right or wrong. Okay, so check. We're going to check from the left or the right, but remember, I always say do the steps first. Okay. So first, plug in. If you plug in here, you'll see on the bottom you're going to get. Okay, so we're going to start with step 1. Okay, so it's going to be 2 squared minus 2 times 2 minus 8 all over 2 squared minus 4, which I don't really care what the top was going to come out to. I noticed already from the start I got 4 minus 4. I'm dividing by 0. Step 1 does not work. So I need to go to step 2. Factor and cancel. Looks like I can probably factor and cancel this. This is the same one as the earlier, which was x minus 4, x plus 2. That is a plus sign right there. All divided by x plus 2, x minus 2. Okay, the x plus 2's cancel, leaving me with my new problem. Yeah, we have a brand new problem. The limit as x approaches 2 of x minus 4 over x minus 2. Remember, this thing and this thing are the exact same thing if you graph them. Okay, let's plug in 2 and see what we get. Okay, 2 minus 4 over 2 minus 2. I have something dividing by 0. Step 2 is not going to work. Okay, so I'm going to have to go to step 3. That means I have a vertical asymptote. Okay, I know I have a vertical asymptote. So this thing here is you're going to focus on the left-hand side and the right-hand side. I want to know if it's going up from the left or if it's going down from the left. So what I'm going to do is I'm going to grab a value very close to 2 but to the left of it. Say 1.9. And I'm going to use this new function I have to deal with it. So I'm going to plug 1.9 into my new function. 1.9, oh, it's kind of hard to put a dot on here. 1.9 minus 4 over 1.9 minus 2. Okay, now I'm grabbing a value so incredibly close to 2. So I'm going to do a little graph here. I'm grabbing a value so incredibly close to 2. If I have one that goes down, I know it's going to be negative. If I have one that goes up, I know it's going to be positive when it's this close to it. So I don't really care what number this becomes. All I care about is the sign. So 1.9 minus 4 is going to give me some negative number. Yeah? 1.9 minus 2 is going to give me some negative number. And whatever that negative number is divided by that negative number, it's going to give me some positive number. So I know it's going to be on the upper half on the left-hand side. So I know I have a vertical asymptote right here at 2. I know the left-hand side is going up towards positive infinity. Let's see what's going on the right-hand side. So I need a number to the right of 2, say 2.1 minus 4 all over 2.1 minus 2. Okay, remember, all I care about is the sign. I don't care about the actual number. 2.1 minus 4 is going to give me some negative. 2.1 minus 2 is going to give me some positive. And then a negative divided by a positive is a negative infinity. Okay, we will be going down from this side. So my graph is going to look like this. So if you're doing this and you have a vertical asymptote and one from the left-hand side is going up, right-hand side is going down, my answer is D and E. It does not approach the same place from the left and the right. So that's what my graph is going to look like. And here's a little graph of it. So you can see it, so you don't believe I'm lying to you. If you can tell, that graph with the blue is the exact same idea as the graph I have here. There's a vertical asymptote at 2. They're going on different sides. And that's how you do that problem. Now I'll give you some time to do that one, and here I'll tell you what the answer is. Pause it if you don't want to know the answer yet. Okay, the answer on this is, oh, let me go back. Okay. The answer on this one is D and E. Okay. The answer for this one up here is D and E as well. Let's see. I know from the left, okay, we're approaching 5. 1, 2, 3, 4, 5. If you plug in 4.9, the top will give you a positive, bottom will give you a negative. So it goes down on this side. And then on the other side, 5.1 would give you positive, 5.1 would give you positive. It goes up on this side. Yeah. Okay, there's that lesson.